Okay, I'm just testing to see how high I can get the temperature on this quartz encased heating element that I got at a thrift store. Coming up on 2400 and it still hasn't melted. At some point, I'm sure it's just going to melt and shut off, but let's see how high it goes. The temperature topped out at 2500 and my thermocouple burned out, but the element didn't, which is kind of interesting. This is where I got the quartz heating element. I just found this at a thrift store and pulled the parts out of it. You can still see the ones in the top. Are silicon carbide spiral heating elements. They're actually igniters from a natural gas furnace. So I have my ohm meter on here. We're at 41, 42 ohms, right in that range. And I never can figure it out on paper, so I just do it like this. So it should run at about 295 watts and 2.7 amps. So let's see how close my calculations were. So for my test setup here, I'm going to put some heat blanket over it. And this is my thermocouple. You got to be careful to not short it out. So here's the final setup. Had a little bit of heat still left in it from my previous test, so it's about 200 F. I got this little gadget off of Amazon. So here's where we are at the moment. It's burning 443 watts, 420, 400. It's coming down as the silicon carbide heats up. It doesn't conduct as efficiently, so the power rating is coming down a bit. But we're already up to red hot. And we're at a temperature of 1879. Let's see how high we can get this to go. Calculated the watts on the first try. This defaulted to 110 and I left it, but we're actually running at 120. So with those numbers, we should be consuming about 351 watts. And we're consuming 362. So that's about as close as you. To summarize, so the heating wire inside of the quartz tubes, I was able to get them to about 2550, but that's pretty much the failure point, and probably wouldn't last very long for repeated use. They're put in a toaster oven. They're meant to get red hot, hot enough to toast bread, but not to stay at 2500 degrees for long periods of time. The silicon carbide, however, is designed to run for years without failing in roughly the circumstances that I had it in there. Inside of a furnace, it wouldn't be insulated so tightly, but it would be plugged directly into mains, running at full power for long periods of time, and expected to last many, many years. So it peaked out at 2333, which is actually pretty good. I'm happy with that. I may try multiples of those or try something else. I have some other silicon carbide I'm working on testing out. The main problem with silicon carbide is it conducts heat very well. So you have to figure out, it conducts electricity very well. So to use it effectively, you have to be able to lower the voltage. So working on a few different angles here, and I may simply use my TIG welding power supply, and we'll see how that goes. That'll be another video coming up before too awful long. But in the end, silicon carbide wins today's demo.